Hi everyone! In this video, we will analyze a hypothesis test and make conclusions. An urban planner states that the average number of public transport trips made by city residents per day is at least 3. You wish to test this claim. A study results in a z-statistic of negative 1.03. Assume the significance level is alpha equals 0.10. What is the p-value and the conclusion for this hypothesis test? The first thing we need to do is identify the null and alternative hypotheses. Looking back at the question, we see that the urban planner is stating that the average meaning that we will be doing our two hypotheses with mu and not a p, because the mu is the average. Trips made by city residents per day is at least 3. When we have the saying at least, this is something can be greater than or even equal to 3. When we have an inequality combined with an equal sign, this must go in the null hypothesis because a null hypothesis must have an equal sign, whether it's equal or maybe lesser than or equal or greater than or equal. An alternative hypothesis will have a lesser than, greater than, or a not equal to sign. So our alternative hypothesis will be the opposite of our null. Since it is at least 3, that means there are more or equal to 3. So our null hypothesis is the opposite, which is less than 3. Now that we've identified both of the hypotheses, let's go ahead and write down the rest of the information that was given to us. We were given the z-statistic of negative 1.03 and a significance level of alpha equaling 0.10. So alpha is 0.10, and our test statistic, or z-statistic, is negative 1.03. We were asked to find the p-value and the conclusion. Looking back at our hypotheses, the alternative hypothesis has a less than sign. It is pointing to the left where the smaller numbers will be because it's less than. So we know that we are dealing with a left-tailed test. We're going to use a tool with Desmos that will help us find the p-value so that we can make our comparison between p and alpha to thus make our conclusion. So we're going to use our tool and we need to move our dot so that it goes down to make a left-tailed test. And then we're going to move the significance level to 0.10. And then we need to move our test statistic, or z-statistic, in the negative direction to negative 1.03. And these get kind of finicky, so we have to make sure that we get it right on negative. There we go. So now we have our z-statistic, our critical value, and it's calculated our p-value for us as well. So we can write that down as our p-value equals 0.1515. Now that we have our p-value, we can compare it to alpha. Our p-value 0.1515 compared to alpha of 0.10. We can see that the p-value is greater than alpha. If p is greater than alpha, then we fail to reject the null. We could have also looked at the test statistic and the critical value of negative 1.303 and negative 1.28. The critical value gives us our cutoff right here for the rejection region, which shows that our t-statistic or test statistic is falling within our fail to reject region. And so we had two ways we could actually have made our conclusion. Either way, we have our p-value that we were asked for, and we have stated our conclusion, which is failing to reject the null, either looking at the p-value in alpha or the test statistic and the critical value. Either way, we're all done.